Captain, and thank you for the nice introduction. So we'll just start out with a brief recap of design science research. Then I'll talk about generating design science knowledge and the level of contribution, and then some different approaches to generating design science knowledge, and then we'll go on to discussion. So first of all, just to tell you a little bit more about my personal experience. So I began my working life as an analyst and software engineer and project manager, which I enjoyed very much. When I, after quite a period of time, returned to academia to do a PhD, I did construct a system. It was a financial planning system, but at that time, design science really wasn't recognised at all. So the approach in those days was to do, though I'd built a system, was to do experiments with it and just test, say, the explanation feature. Since I've been an academic, I've had various funding from government bodies mainly. One was for the project with beef producers about supply chain management. Again, at that point, it wasn't called design science. We'd call it action design research. And the government was kind enough to give me an Order of Australia for that work. Also had a large project in Bangladesh. We did describe that as action design research. And not too long ago, we've been working on interface design for an AI system for suicide prevention. And I've still got a project going about knowledge sharing interventions with Indigenous Australians. But now I'm really retired now, so I don't do a great deal of academic work anymore. And I do have a business card that describes me as an artist. So I'm now an artist, which is another design field, which is very enjoyable. An introduction to design science research. So there's all different sorts of knowledge and different disciplines that use something like a design science approach. And really the sort of work that's done, it's very old. So it's been around forever, since, especially in engineering and medicine and applied science. But really up until relatively recently, this type of work could be done using step-by-step approaches, a fairly rational approach. So, for example, if you wanted to build a bridge, such as the Romans aqueduct, you had the knowledge there, and it was maybe written down, or it was in people's head. But it wasn't that difficult to capture the knowledge and pass it on. But once we got to computers, the knowledge became a lot more complex. And not just that it's more complex, but one of the big problems is it just changes so quickly. And we're seeing that now with AI. So you think you're sort of coming to grips with knowledge about one sort of technology, and then it just changes again. So the term design science was brought in the 1960s by someone called Buckminster Fuller. And we did have work in other fields, such as Schoen in 1983, who wrote about the reflective practitioner. A little bit more history. Christopher Alexander in architecture had what was called the patterns approach. But the main work in which you can usefully go back and reread this is Herbert Science work, Science of the Artificial. And he said that we needed a science of design, and this meant having something that was useful, that helped us design things, but it was also intellectually tough. And that's a difficulty, because for a long time, disciplines like engineering haven't been really regarded as being as sort of legitimate as pure science. And we had a lot more work in different areas, in management accounting, education. In information systems, we had Juhani Ivory, 1991, he called it systemeering. At J. Nunamaker, referred to systems development approach. March and Smith started talking about design science. And then there was the major article by Alhevner and others in MISQ, which really legitimized the idea in mainstream IS. And just in case people sometimes find it difficult to describe what design knowledge is, and it's the type of knowledge that says what might be, whereas other types of knowledge say what is. Now, we still get trouble with this. You'll see a journal article come in and someone will say, where's the theory? And they're looking for something like a management theory. They're looking like for this sort of theory, and they don't seem to think in their head that it could be this type of theory. And just to say how different they are, if we're using this what is type theory, we've got different logics. We've got a deductive logic usually, and whereas with design science, we've got what you might call an action logic. And there's a lot of work on this, on action logics. And saying it again, if we've got descriptive knowledge, we say something like mechanism 1 is associated with outcome 1. That does not follow. It does not follow necessarily that M1 is necessary to achieve O1, because there may be other ways of getting to O1. So they're just different ways. They're just completely different logics. Now, finding the principles and mechanisms that allow you to do this can require a lot of creativity and hard work, which is why design knowledge is so valuable. And generating design science knowledge. So there's lots of different ways that we can come to design knowledge. We can use methods of induction, deduction, abduction, which is more like a form of guessing. Can involve creativity and imagination, likely to be an iterative process. This paper by Goldkuhl is useful here because it starts to give us an idea of where the design knowledge might come from. And just, I think probably most people realise there's controversy about many aspects of design knowledge creation. Okay, and the illustration here is the butterfly. If you're interested in art, you'll find there's design principles that are represented in that artwork, such as the rule of thirds. So again, design knowledge has been around a long time. Okay, so the very helpful review by Engel et al., 2019, and they looked at the different types of strategies people had used in journal articles to produce design knowledge. They found the major part was deductive and less was inductive. And then there was a mixture of 33%. So deductive means that the people writing the article said, we've started out with such and such a theory. It might have been design theory, or it might have been some other theory. And we worked out from that there were certain design principles that should be represented in our artifact. And then we went ahead and built it and tested it. Inductive, you might have built the thing first, the artifact first, and then worked out afterwards what design principles were represented in it. Now, the paper that Al Hevener and I wrote in 2013 in MISQ, this was just part of the paper, and we were a bit surprised that people used this so much afterwards. But we looked at what level of contribution you might be going to make. So if you are producing design knowledge, it's helpful for you to try and position it using this. And a lot of people do this in their article. They'll say, mostly they say they're doing level 2. So level 1 means you just build an artifact and you say, okay, here's this thing. This is a faster sorting algorithm than has ever been had for this particular problem. Here you try and you have some description, you try and get a little bit more higher level of generality. And so you make it more you have a design principle in order to achieve a very fast sorting time, use an algorithm that relies on some type of mechanism. And then if you go even further, if you start to bring lots of different design knowledge together, then you might be getting to the stage of having a fairly general theory. I don't always like using the word theory. I often would quite more happily use bodies of knowledge, because the word theory just means so many different things to different people. And I've also found that I myself I think when I wrote that paper with David Jones in 2007, we showed how you could specify a theory. And I now think that it's not very likely that many of us can actually produce a whole theory. We're more likely to be at this level where we have some sort of principles. And these helpful studies, again, there was the one by Engel, and you can see what proportion of studies were of each type. And this was a review of Desirist publications. And so you can see most of the articles aimed at producing construct models or methods or design principles. Very few tried to produce a design theory. And a similar situation with an analysis of the basket of 8 by Engel et al. So biggest proportion is at that level. So you can tell me later whether you think that's helpful, whether you have troubles thinking that way. Now, people who want to do design science research probably normally think of this type of work, a traditional artifact development approach. But there are some other approaches that you can use. This would be the most common approach. So those, when we looked here, they would have been looking at that first strategy where you in some way build an artifact. But there are some other types of work that you can do that are helpful for gathering design knowledge. So I thought I'd mention these as well. So the first approach is the traditional artifact development approach. And this is quite good to use because we now have methods that are accepted. So we've got especially the method by Peffers et al. 2008, which starts off, recognize problem, build artifact, test, report knowledge. It's interesting, I wrote a paper just recently with a colleague from project management, an editorial, and we did a little bit of a review there, and we found that even in project management, people are using that Peffers et al. Approach. So they've just started using it all by themselves. We find that it's being used. There's another journal come out, I think it is a European journal, Journal of Business Venturing Design, and you'll also find that approach used. Now, the exact form of the method may not matter so much as long as it has credibility, but lots of people use Peffers et al. Because it's just so well accepted. And personally, I think we should be open-minded if we're reviewers or editors about what's being used, because someone might have had a flash of brilliance. They might have just imagined something. They didn't actually work through the Peffers et al. Process model. We do need to be assured that the knowledge is reliable. So we do need some sort of testing and evaluation. Often people use the Venables et al. Framework. Now, this is a bit of a problem with design science research, because we'll often find reviewers, we've got the people who've built an artifact, which might have taken them a lot of time to do. And then if you write a journal article, sometimes the reviewers want you to put in an evaluation that's as rigorous as would have been done, say, in an experimental work of someone else's artifact. So it doesn't seem fair that you've got to build the artifact and then go and do a really enormous amount of testing as well. So quite often, fortunately, people will build the artifact and do some type of indicative testing to show that it works. And it's easier if you've got a something like an algorithm for, say, AI, where you've got a test bed and you can run it through lots of times. But if you're going, if you've got to get to the stage of either doing experiments or doing in-depth case studies, really you've got almost two studies. And I'd say, the methods you've used need to be convincing, but let's not be too strict about what people use. So this is one example I've picked of just one of many. It seemed quite a good one. It appeared in Aegis, and you can see it's at the moment it's had Google Scholars citations of 67, which is not bad. And I looked at the papers that had cited this. Many of them seem to be either reviews or they are work again in some sort of environmental or sustainability type work. So this was a model-driven decision support system for repurposing electric vehicle batteries. Bit of a mouthful, that title. It's relatively straightforward design science research with the designers producing it themselves. So it was a primary study and it was the interior mode research. The people who produced it also evaluated it, and it was a lot of effort. Now, we'll just look at what they did. So this is a fairly normal sort of structure for a design science paper. So they set up the problem, should be a class of problems. You have to just demonstrate that it's an important problem, not just from an academic point of view, but for someone out in the world. You give the research background. So it's a decision support system, so they looked at that. They showed that the repurposing was a class of decision support systems for that problem area. Now, I don't want to criticise the article, but this is something I thought when I read it, and this is not uncommon with design science research. They didn't really do a careful literature review for repurposing decision support systems in general. So that's their class of problem. So you might have thought that they'd looked at a good literature review of that area. So you've gone through, you've got decision support systems at the top, and you've got described the problem area of the electric vehicle batteries, and then you come to like the little area you're looking at. You really should be looking to see who else in the world has tried to solve this problem. Because otherwise, when you get down here, you can't really claim that you're making an original contribution to knowledge if you haven't done that. Now, it's not just me saying this. So I went to a workshop last week in Sydney, and it was about research with impact. And several of the speakers, it was a developmental workshop, several of the speakers had comments saying, someone else has done that. You might be doing this in such and such a country, but if you go to another country, the government there has got studies on this. So you could see there was, it's not good. Those people would have run into problems possibly once they tried to write that up. The research method. So this one's exaptation research. That got different types of knowledge and joined them together and brought them over and applied them to this class of DSS for repurposing. The artifact description. They showed the decision models, they had the maths in the appendix, and they showed you the user interface. And they showed how they'd got the parameters from a literature search. I mean, this is a different literature search from here. Oh, sorry about this, there we are. Okay, so it's very, very thorough study. And then they'd done a field experiment as a demonstration to test propositions. Again, that's thorough. They've gone through and done quite a good testing of the thing. But see, this is another issue. They've just referred to it as a I'm going to have to move they would just refer to it as an artifact or our DSS. So I found from experience, it's very helpful if you've built an artifact to try and give it some sort of distinctive name. So it's not very good just to keep talking about it as an artifact or our DSS. It would have been better perhaps to call it something like, what's distinctive about this? It used a bipartite matching problem. So we got a matching artifact or how, yes. See, they just say it's the first for repurposing used batteries. But that's just like the artifact. If you want to go up to a bit more general, what's it actually adding to knowledge apart from that? Is it showing you something that could be used in other repurposing problems? The fact maybe nobody else has used this bipartite matching technique. So again, when we've had workshops and we've pushed people who are presenting to find a name for their artifact, they found that that's helped crystallize what's unique. Like last week, someone was doing I think it was something to try and suggest, they were using persuasion theory, but they were also trying to nudge people to adopt some environmentally friendly habit. So someone said, could we call it a push-pull method? So we were pushing and pulling with persuasion. So if you do that, you sort of see that you're getting to what's distinctive about your own work. I don't think they're adopting push-pull. It probably is not a particularly good name, but if you can brainstorm to see if you can get a name to describe your artifact. Now, I'll probably spend most time on this because this particular way of doing design science is the most general way, the most used way, but I'll just show you some other things. Oh, there's action design research. So this is generally more where you work with a big organisation. You probably might not have a particular artifact. You might end up more with some sort of organisational method. So this project was in Bangladesh. You can see Shirley right up the end there. And we went over there. It took 5 years, several trips. And we were looking at capacity building with IT, trying to get the government there, the government departments, to use IT mainly as a way of making their processes more transparent, because they have a problem with lack of transparency. And in the end, we thought that would lead to more accessible citizen services. So the artifact we produced was a change process. And we had some different principles in it. Some of them are not, we presented the principles really as a package. We said some of the principles at the lower level weren't particularly new, but putting them together in this environment as a package was something new. It took a very long time for us to get that paper published. 5 reviews, and a long time. Okay, so there's something else that when I was working with Alexander Matchey and Jeff Parsons, we might call it design-oriented behavioural research. So it might look like the ordinary behavioural research, but it's very closely linked to design in the sense that you can turn around the knowledge you get to give design principles. So, for example, the work I did a long time ago on explanation facilities, we found that if you put an explanation facility into a knowledge-based system, the system was likely to be more trustworthy. So, the design principle is include explanation facilities in order to make your knowledge system more trustworthy. So the causal links, if you're doing an experiment, they can be fairly readily established. Now, it might be that you can do this as part of a bigger project if you've got a team working on things, that you might have some people doing this sort of work, doing experiments with the artifacts you've built. Isaac Benbasat uses this approach. He wouldn't normally call himself a design science researcher, but his students and he have certainly produced work that adds to design knowledge. And you can see Isaac has got an incredible number of citations for what he's done. So that's one example of one of their papers. And see, they would have called that an experimental vehicle, but they've still built something that you can get design ideas from. How to design interfaces for product recommendation agents. So another thing which I personally think is very valuable is to do reviews that lead to design knowledge. And I would suggest that this was a good thing for PhD students to do quite early on in their course of study, and it quite often can be publishable as a standalone paper before they go into the artifact construction. So medicine used something called the PICO model. Now these sorts of reviews are different from other types of literature reviews because you focus on this sort of schema for organising your knowledge. So medicine used the idea of population, intervention, comparators and outcome. And something that we've used more is taken from management, and it's CMO logic, where you look at context, interventions, mechanisms and outcomes. So that's one example there from Phil B. et al. And we've used this ourselves. So the work I was doing with some other people on knowledge interventions with Indigenous Australians, we did a scoping review, which meant that we could use different types of article. So they didn't all have to be articles in our journals. In fact, it's better if they're not. Again, that one we saw last week, the person there really should have been looking at what governments were doing, because quite often you would find governments have been doing interventions that might be relevant to you, to your work, and they've done evaluations. So for this, we found 7 primary studies, and so that's sort of one study we looked at. Now I haven't put this into that CMO logic. So if you've got the paper, the Gregor et al. Paper, in the appendix, there's an example of one study presented against this CMO logic. So there's one study that we looked at though, and it was about a website that was to help Aboriginal people with diabetes. And from this scoping review, though it won't give you the definitive evidence that you'd get if you did some sort of overall quantitative analysis of the different studies, it can give you an indication of what's been found. So, for example, with that area, we found that all the interventions which only had positive outcomes had taken account of Indigenous ways of knowing, being and doing to some extent. And in fact, I think we found in nearly all of them that actually had Indigenous people on the team. It seems common sense, but again, some people don't do that. They'll go and do work and not include the Indigenous people in the design of whatever it is they're doing. It was quite funny reading some of them. I mean, these people here about the website, they were quite scathing about what had been done before. They said, oh, it's just like they took a website for other Australians and just stuck some Indigenous art on it. Whereas when they designed it as if it was a family yarning around a kitchen table. So it was quite different and much more suitable for their culture. Okay, and the last one I'll talk about design theory development. This is not easy. Very few examples of a whole design theory. One is Daniel Moody, who just happens to be Australian as well. And he called this the physics of notation towards a scientific theory of constructing visual notations. And that was very carefully constructed. And he used the design theory framework we had in 2007. And he got his principles from synthesis of theory and empirical studies plus boundary conditions. So it's good. And I think it's been very useful to people. Okay, we've got through it now. How's that? 35 minutes.
Perfect. Thank you so much, Shirley. Nicholas,
What
I
is
think we can.
this? Is the gold, the pot of gold at the end. I really
Perfect.
like the sculptor's work. Okay, so will we lose the slide and go into just discussion?